Mountains on Earth are impressive, no doubt. But what about the mountains in space? They are a completely different game now. Recently, NASA scientists discovered two mountains on Pluto's surface that rose nearly 6.5 kilometers into the atmosphere and probably emitted ice rather than lava. However, it's not the most peculiar peak to have appeared in our solar system. Here are a few of the most surreal landmarks ever found in space. Mars' Olympus Mons. A sizable shield volcano on Mars is called Olympus Mons. According to data from the Mars Orbiter Laser Altimeter, the volcano is over 21.9 kilometers, 13.6 miles or 72,000 feet high. Olympus Mons is about 2.5 times higher than Mount Everest above sea level. It is one of the biggest volcanoes, the tallest mountain on a planet, and roughly tied with Rhea Silvia for the title of tallest mountain ever found in the solar system. It is connected to Mars' Tharsis Montes, a sizable volcanic region. Olympus Mons, the youngest of Mars' major volcanoes, formed during the Hesperian period, with eruptions continuing well into the Amazonian. Astronomers had been aware of it since the late 19th century, as the albedo feature Nix Olympica, Latin for Olympic snow. Long before space probes confirmed it to be a mountain, its mountainous nature was suspected. The volcano is situated in the western hemisphere of Mars, with its center at 18 degrees 39 minutes north, 226 degrees 12 minutes east, not far from the Tharsis Bulge's northwest corner. The volcano's central and eastern portions are located in the adjacent Tharsis Quadrangle, while the volcano's western portion is located in the Amazon's Quadrangle. The International Astronomical Union has given two impact craters on Olympus Mons preliminary names. They are the 10.4 kilometer diameter, 6.5 mile Pongbochi crater, 17 degrees 10 minutes north, 226 degrees 25 minutes east, and the 15.6 kilometer, 9.7 mile Karzok crater, 18 degrees 25 minutes north, 228 degrees 5 minutes east. Shergottites, the most common class of Martian meteorites, are thought to have originated from two of the craters, which make them noteworthy. Maxwell Montes, Venus. Maxwell Montes is 11 kilometers, 36,000 feet high, and is situated on Ishtar Terra, the northerner of the planet's two main highlands. It is approximately 853 kilometers, 530 miles long, and 700 kilometers, 435 miles wide, rising about 6.4 kilometers above and to the east of Lakshmi Planum, 20,000 feet above and 4 miles, 6.4 kilometers, to the east. The eastern slopes gradually descend into Fortuna Tesserae, while the western slopes are very steep. Its elevation makes it the coolest and least pressurized place on Venus's surface, with temperatures around 380 degrees Celsius, 716 degrees Fahrenheit, and 45 bars, 44 ATM, respectively. It is debatable where the Maxwell Montes mountain belt and the Lakshmi Planum came from. One theory contends that they deployed over a hot plume of material rising from the planet's interior, while another contends that the area is being compressed, pushed together from all sides, causing material to fall into the planet's interior. Maxwell Montes and Fortuna Tesserae's broad ridges and valleys provide evidence that the topography is a result of compression. Later extensional faults split the parallel ridges and valleys. In comparison to other compressional mountain ranges near Lakshmi Planum, Maxwell Montes is extremely tall, which suggests that its origins are more complicated. The majority of Maxwell Montes has a radar return that is bright, which is typical of Venus at high altitudes. It is believed that this phenomenon is caused by the presence of a mineral, possibly metallic snow. Pyrite and tellurium were two early suggestions. More recently, lead sulfide and bismuth sulfide have been suggested. In 1967, astronomers at the American Arecibo Radio Telescope in Puerto Rico discovered the vast highland on Venus that later earned the name Maxwell Montes. They did this by using radar to pierce through the thick, persistent clouds in the Venusian atmosphere and make observations of the surface. In order to conduct radar observations of the surface of Venus, the spacecraft Pioneer Venus 1 entered orbit around the planet in 1978. The first topographic map of Venus' surface was made possible by these observations, which also proved that a spot inside Maxwell Montes is the planet's highest point above its mean surface level. James Clerk Maxwell's work in mathematical physics predicted the existence of radio waves, which made radar and, consequently, the surface observations of Venus possible. Maxwell Montes is named in his honor. The three exceptions to the rule that Venus's surface features must be named for women are Maxwell Montes, Alpha Regio, and Beta Regio. The International Astronomical Union's Working Group for Planetary System Nomenclature, IAU, WGPSN, approved the name between 1976 and 1979 after Ray Juergens first proposed it in 1970 at Tommy Gold's urging. Equatorial Ridge, Iapetus, Saturn Moon. The tallest mountain on Iapetus, a moon of Saturn, is the Equatorial Ridge. The third tallest mountain structure in the solar system, it rises to a height of 20 kilometers, 12 miles. Most of Iapetus's equator is traversed by it. The 2004 Cassini probe made the discovery. Nobody knows where the ridge came from. Near the bright trailing hemisphere of Iapetus, there are bright regions on the sides of the Equatorial Ridge that are known as the Voyager Mountains because they appear to be mountains in Voyager 2 images. When the Cassini spacecraft photographed Iapetus on December 31, 2004, the Equatorial Ridge of Iapetus was found. Some of the tallest mountains in the solar system can be found in the ridge, where some of its peaks rise more than 20 kilometers above the nearby plains. The ridge creates a complex system that includes lone peaks, sections longer than 200 kilometers, and sections with three nearly parallel ridges. There is no ridge within the bright regions, but there are several lone 10-kilometer peaks along the equator. The ridge system is heavily cratered, indicating its age. Iapetus resembles a walnut because of the prominent equatorial bulge. The ridge's formation is unclear. One challenge is figuring out why it almost exactly follows the equator. At least 4 current theories have been put forth, but none of them provide an explanation for why the ridge is restricted to Cassini Regio. According to a group of scientists working on the Cassini mission, the ridge might be a holdover from the young Iapetus's oblate shape when it rotated more quickly than it does now. A maximum rotational period of 17 hours is inferred from the ridge's height. Iapetus must have been heated by the radioactive decay of aluminum-26. If it cooled quickly enough to maintain the ridge, but was plastic for long enough for Saturn's tides to have slowed the rotation to its current 79-day tidally locked rotation. The solar nebula from which Saturn formed appears to have contained a lot of this isotope, but it has since completely decayed. Iapetus must have formed sooner than anticipated, only 2 million years after the asteroids first started to form, based on the amounts of aluminum-26 required to heat it to the necessary temperature. The ridge might have been made of icy materials that welled up below the surface and then solidified. This hypothesis requires that the rotational axis would have been pushed to its present location by the ridge if it had formed away from the location of the equator at the time. Due to the size of its hill sphere, Iapetus may have had a ring system when it formed, and the equatorial ridge may have been created by the collisional accretion of this ring. Caloris Montes, Mercury. The Caloris Montes, also known as Heat's Mountains, are a group of mountains located on Mercury. The Shakespeare quadrangle's Caloris Basin's mountainous rim is where they begin. They are a system of linear hills and valleys that spread out more than 1,000 kilometers to the northeast. The range is made up of numerous rectilinear massifs that are 1 to 3 kilometers high and 10 to 50 kilometers long. Most of the massifs are elongated radially from the basin's center, and they are divided by hackly floored radial troughs and gouge-like structures. The massive surfaces are rough. The inner edge of the basin, where steep inward-facing scarps are frequent and grade outward into smaller massifs and blocks, is where they are best developed. The range denotes the peak of the most noticeable ring structure in the area of Caloris. Near 18 degrees and 184.5 degrees is where the type area is located, FTS 229. It is believed to be made up of uplifted pre-basin bedrock that has been deeply covered by Caloris late ejecta. The outer limit of crater excavation is roughly the inner boundary. The so-called Imbrium sculpture on the Moon is comparable to the Caloris Montes. It is generally accepted that the formation of this specific type of lineated surface feature involved the excavation of the planet's crust by secondary projectiles during the formation of the large basins. The Caloris group of formations, which were created by the impact of the Caloris Basin, only includes the Caloris Montes as its innermost formation. There's a gap in the Caloris Montes that faces southeast. Its cause is unknown, but it resembles the gap on the east side of the Imbrium Basin where the mountain ring splits the Serenitatis Basin. On Mercury, however, there is no proof that a pre-existing basin existed east of Caloris. The Elysium Mons. Elysium Mons is a volcano on Mars that can be found in the volcanic province of Elysium at 25.02 degrees north, 147.21 degrees east in the planet's eastern hemisphere. It is the third tallest Martian mountain in terms of relief and the fourth highest in elevation, rising approximately 12.6 kilometers, 41,000 feet above its base, and approximately 14.1 kilometers, 46,000 feet above the Martian datum. It has a summit caldera that is approximately 14 kilometers, 8.7 miles across, and a diameter of about 240 kilometers, 150 miles. The smaller volcanoes, Elbor Tholos and Hecate Tholos, are on either side. Images from the Mariner 9 orbiter's return in 1972 led to the discovery of Elysium Mons. A comparison between Emikusi and Elysium Mons has been made using a terrestrial volcano in Chad. Despite having summit calderas that are roughly the same size on both shield volcanoes, Elysium Mons is 6 times higher and 3.5 times larger in diameter than its earthly counterpart. So this is all for today. I hope you enjoyed seeing some of the wonders of nature not on Earth, but on other planets. If you had fun, please like the video, subscribe to our channel, and hit the bell icon because we keep bringing such amazing things for you.